going to look at exponential equations, and I'd like to motivate exponential equations with a few examples. So let's start with example A. Suppose a ball bounces to 2/3 of its previous height with each successive bounce. We start by dropping the ball from a height of 108 inches. Make a table for the first 5 heights of the ball. Use 1 to 5 as the inputs and the heights of the ball as the outputs. So let's just get a visual for what's going on. We have the ground. That would be like, that's where our height of 0 is. And we're going to drop the ball from a height of 108 inches off the ground. The ball's going to come down. It's going to bounce up to 2/3 of its previous height. So then the question is, what is this height? Right? Then the ball's going to come down and it's going to bounce to 2/3 of its previous height. Should hit the ground there. And the question is, what is this height, etc., etc. So for our table, we can do number of bounces and height. Now, I know the directions here say use 1 through 5 as the input, so we could do that. That's after 1 bounce, after 2 bounce, after 3 bounces, 4, 5. But let's go ahead and include 0. You know, what's the height after 0 bounces? After no bounces, the height is at 108 inches. All right, so after 1 bounce, it's going to be 2/3 of 108. So it's going to be 108 times 2/3. And we can use our calculator to figure that out. We can go 108 times 2 divided by 3 is 72. Some of you have, fractions on your calculators and stuff like that. All right, so that is 72. Okay. That's after 1 bounce. It comes up to 72. So after 2 bounces, we're going to take a height of 72 and we're going to multiply that by 2/3. So 72 times 2 divided by 3 is 48. And then we'll do 48 times 2/3. Let's see. So 48 times 2/3 is 32. And then after 4 bounces, might as well write these over here. So that's 48, and then it comes down again, and it bounces up to 32. This is very rough, right? 32 times 2/3. That's not going to come out nice because 3 doesn't go into 32. Times 2 divided by 3, 21 1/3. 21.3 repeating is 21 1/3. Next bounce, 21 1/3. And lastly, we'll take that and multiply that by 2/3. And we get 14.2 repeating, which is 14 2/9. When 1 digit repeats, it's ninths. That's free. Okay, 14.2, just to get a visual of what's happening there. So now what I want you to do is I want you to come over here and I want you to graph the data from the table. Choose appropriate scales from the X and Y axis. So let's talk about this a little bit. Let's draw, actually let's make this a little bit thicker or a different color so we could see it. Let's draw the X-axis or Y-axis and the X-axis. Now I really want to get a visual of what's happening here, so I only have 5 bounces. I don't really want to go, this is going to be the number of bounces on the X-axis. I don't want to make each line worth 1, 2, 3, 4, 5. It's going to be too squished. So maybe I'll, kind of go out like this and make that 1, 2, just do every 2 lines. At least that'll spread it out a little bit. 4, 5. We didn't do 6 and 7, but we certainly could. Okay, then for the height, I know I need to go up to 108 because that's where it's starting. Again, I want to try to spread this out and use as much of the graph as I can. Maybe we go by 5s. Let's see, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. That's not going to fit. 60, 70, 80, 90. Close, if I would have made my x-axis down a little bit. All right, we'll just go by tens. That's fine. So we can go 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. Okay, so we're going to start off. We had 0 bounces. We had a height of 108, so it's going to start about right there. So go ahead and graph the data from the table. And you can pause the video and do that. Alright, so you should get something that kind of looks like this. And we could do a couple more. It might be interesting. Let's see, our last number was 14.2, so if we times that by 2/3, we get 9.48. So that'd be like here on 6. And then if we times by 2/3, we get 6.3. That would be 7. Are we ever going to get to 0? Times 2/3. 4 point something. You know, theoretically, we're never going to get to 0 because we are taking 2/3 of it, so we're always going to have something left. Obviously, the ball does stop bouncing for other physics reasons. But we get this kind of a situation right here, okay? And this is what we call exponential decay. So, is the graph a function? Yes, it's a function. Because for each input, there's exactly one output. That's what makes a function. Is this function increasing or decreasing? Whenever you're asked this question, it is really about the y values. It's asking about the y values. As x increases, what is happening to y? As the bounces are increasing, what's happening to y, which is our height in inches? That's decreasing. This is a decreasing function. Okay, now, find a formula for the nth height of the ball. So this can be a bit of a leap, but let's go back and look at our table and think about what happened here. So we started with 108, then we did 108 times 2/3. Now, for this one, for 48, another way we could think of this is starting from 108. If I started from 108, to get to the 48, I multiplied by 2/3 to get to the 72, and then I multiplied by 2/3 again to get to 48. So 48 is 108 times 2/3 to the second power. Now, let's think about how we get to 32. Starting at 108, how do we get down to 32? I have to multiply by 2/3, multiply by 2/3, multiply by 2/3. So how many times did I multiply 108 by 2/3? 3 times. How do I get to the next one? Well, I would take 108 and 2/3, and if I have to times 2/3 to the 4th power because it's after 4 bounces. The question is asking us to write a formula after n bounces. Well, I started at 108, and I'm going to have to multiply that 108 by 2/3 to whatever number of bounces that I need to get to the height, because each height is 2/3 of each successive bounce. So see, when you're multiplying by 2/3, you're multiplying by 2/3 an additional time for each bounce. And so what that's doing is increasing the number of times you're multiplying by 2/3, which is represented by the exponent. The number of bounces is equivalent to the exponent. Now this also works for the 0 power, because anything to the 0 power is 1. And a lot of people don't know that. That's kind of a weird little property. But if I take 2/3 to the 0 power, that's equivalent to 1 times 1, and that will give you 108, which is what we want. So our formula for the nth height is y equals 108 times 2/3 to the nth power. All right, and I'm using n for x. We could say the xth height or something like that. I'm using n as this variable, and I'm using y as this variable here. You want to define your variables. So this isn't linear, right? There's not a constant decrease. If you look between here, I lost about, if I subtract these two numbers, I get, what do I get? 36. So I lost 36 inches of height on this first bounce. If I subtract these two numbers, I get 24. So I lost less height here. If I subtract these two numbers, I get 16. I'm losing less and less height. That makes it not a linear